Hello, this is the Unit 1 extension and Unit 1.5 test review. I'm just going to verbally go through each of the items on the review, so you can either listen and just review that way, or if you want to listen and get the extra points, then you can write them out and turn in your review tomorrow before the test. All right, the first thing is agonists versus antagonists. These are substances that are added to the body, like drugs or medications. An agonist is any kind of substance that can mimic a neurotransmitter. So, for example, cocaine is an agonist for dopamine, so it's going to enhance the effects of dopamine. An antagonist is going to block the effects of a neurotransmitter. So if it was an antagonist for dopamine, then it would block the effects of dopamine. Characteristics of different sleep disorders, a few of them. We know insomnia is when a person has trouble falling asleep or staying asleep. Sleep apnea is when a person stops breathing throughout the night. REM sleep behavior disorder is when a person moves in, they fail to become paralyzed during sleep and they move in aggressive and violent ways while they're sleeping. Narcolepsy, a person has sudden and overwhelming sleepiness and often will fall right into REM sleep. And somnambulism is sleepwalking. Stages of sleep. We want to remember that there's 4 stages, and we call stages 1 through 4 non-REM sleep. And really, a lot of textbooks now drop stage 4, and they just call stages 1 through 3. And then REM sleep is rapid eye movement, and that's our stage. It goes 1, 2, 3, 4, 3, 2, 1, REM. So REM is near the beginning when we're close to awake. That's when dreaming happens. The amygdala is active, so our most vivid dreaming happens. Drug tolerance versus withdrawal. So drug tolerance is when a person has used a substance long enough that their body now needs more of the substance to have the same effect. Withdrawal is when a person suddenly stops using a substance and their body feels physical consequences for stopping taking the drug. Sometimes it could be as severe as hallucinations, but more often it's something like headaches, shaking, and nausea. Some of the primary effects of the different drugs that we've talked about in class. Cocaine, we talked about as an agonist for dopamine, so it's going to create a high, but because it acts on dopamine, it also affects movement, so sometimes people are real fidgety. Alcohol, we know, can depress or slow down the central nervous system. All right, amphetamines are uppers and they increase activity of the central nervous system. Sometimes it causes people to lose their appetite. So people who are hooked on methamphetamines are often skinny. Opiates are agonists for endorphins, and we know that endorphins block pain. So opiates create a high by blocking pain and making them feel good. And then hallucinogens can create altered states of reality. All right, the hearing sensory pathway, it starts with the pinna by funneling sound waves down into the auditory canal. Those sound waves then vibrate against the eardrum, also called the tympanic membrane. Then it puts pressure, the vibrations put pressure against the ossicles, which include the hammer anvil stirrup, also called the malleus incus and stapes. Then that pressure hits the oval window, which is the opening to the cochlea. And then inside the cochlea, fluid is moving along the basilar membrane and the organ of Corti, where transduction occurs. Now a neural impulse will exit the cochlea and go down the auditory nerve, where it meets the thalamus. And then the thalamus directs that auditory signal to the auditory cortex of the temporal lobe. For vision, the vision sensory pathway starts with the cornea, which is the outer window of the eye, and then light comes through the pupil, and then it hits the lens. The lens shape is adapted through accommodation, where the lens is constantly moving because of accommodation to see close and distant objects. After it hits the lens, it travels through the vitreous body, which is the main part of the eye, and then it hits the back of the eye, which is the retina, where all the photoreceptors are. It passes through the ganglion cells, the rods and cones, and then the bipolar cells, where transduction happens. Once it passes through there, the neural signal travels on the optic nerve out to the back of the eye to the thalamus, where the signal is directed to the occipital lobe and the visual cortex. Binocular depth cues. Binocular cues are ones that involve two eyes to see depth. Convergence helps us to measure depth by looking at how much your eyeballs turn inward as objects get closer to your face. And then retinal disparity is where your brain is analyzing how different the image that each eye sees. If your left and right eyes are seeing a big difference, it tells it that the object is close. If there's not a big disparity between what the retinas see, then it's a distant object. Bottom-up and top-down processing are part of perception and how our brain organizes information. Bottom-up processing is the idea that we see the parts before the whole. So this would be like being able to pick out individual sounds within a melody, or being able to pick out individual instruments within an orchestra, or individual flavors within an overall taste. Top-down processing is seeing the whole image first. So that would be like being able to read a paragraph even though you can't see, or even though a lot of the words maybe are missing letters, or being able to recognize an image even though pieces of the image are missing, kind of like the picture of the cat that we saw where it was really just a bunch of dots and dashes. The cochlea and the basilar membrane, the organ of Corti, already talked about those, but those are all related to transduction. The cochlea is in the ear, and the basilar membrane is the lining of the cochlea, and the organ of Corti is part of the hair cells that does transduction. Color deficiency is what we call color blindness, and that happens when there is damage to any of the cones. So we have red, green, and blue cones, so if any of those are damaged, we have color deficiency. Depth perception is done through either monocular or binocular cues. Monocular cues are the ones that involve only one eye, and they're things like linear perspective and interposition and texture gradient. And then the binocular cues are the things like retinal disparity and convergence. Let's see, the Gestalt principles. These are all things that are involved in perception and are explanations of how your brain is able to complete or create a whole image even when it's missing pieces. With closure, that's when maybe there are dashes or dots, and then your brain tends to see a whole line. Figuregram, the example of that was like the vase and the two faces, where you can focus on one color and see one image, and then the other is in the background, or you can refocus to a different color and a different figure is in the foreground and one is in the background. Proximity and similarity, make sure that you're looking for words that are key here. So proximity, like they're in a close location to each other, and that helps you to identify them. And then similarity, that the objects look like each other or are similar. Gustatory system is your sense of taste. Just noticeable difference in Weber's law. Just noticeable difference is the idea that when there's already a stimulus present, it is how much change is necessary for you to notice that there's a difference. So if the lights are already on, how many more lights have to come on before you know that it's brighter in a room? Weber's law helps to explain that. It says if the initial stimulus is small, then you only need a small change to notice a difference. So if it's totally dark in a room, you only need a little bit of light to be able to see a change. But Weber's law says if the initial stimulus is large, you need a large change to notice a difference. So if the room is already really bright, you'll have to add lots of lights to make it look brighter. Your kinesthetic sense is your sense of body position and being able to control your body's limbs and the movement. It does incorporate balance, but it's more about being able to move all the parts of your body, like walking down the stairs without having to look. That's part of vestibular sense, or a ballet dancer moving around. That's kinesthetic sense. The lens and accommodation, again, the lens is the flexible part of the eye, and accommodation is the idea that the lens is constantly changing its shape to adjust to looking at near objects or far objects to be able to detect distance. The monocular depth cues are ways to perceive depth using only one eye. And this can be done in two-dimensional images or in real life, only using one eye. Relative clarity says that items or objects that are closer to you or closer in relation to you are going to look more clear. Relative size says that objects that are farther away will appear smaller. Texture gradient is pretty much the same thing. Relative clarity does actually consider that there's dust in the atmosphere, and that affects the clarity. Texture gradient says that it has to do with their grouping, and when things are farther away in groups, you see less details. Linear perspectives then was when we have two parallel lines that they look like they're coming together in the distance, and then interposition has to do with the overlapping of objects when you can see more of an object that's closer to you and that it's blocking something behind it. That's how we know which object is closer and which one is farther away. Your olfactory system is your sense of smell. The opponent process theory and trichromatic theories are both theories about color vision. The opponent process theory is the one that says that each of your cones can see the opposite colors through after images. So when we looked at the example of the American flag, where we looked at like turquoise, or we looked at the like green and black flag, and we fatigued our rods and cones, and then we saw the red, white, and blue flag. Trichromatic theory, think three colors. This is the one that says by mixing the three colors, you can see all the colors of the visual spectrum. Perceptual set is the idea that your views and perspectives all can affect what you actually see. So if you are expecting to hear a drug message or some other kind of message in music, you're more likely to perceive that. If somebody tells you a movie is going to be really scary, then you are more likely to perceive it as scary, even if you didn't necessarily, even if the movie really wasn't that scary. Already went over parts of the eye in the visual pathway, but key ones there are the retina and the rods and the cones. Parts of the ear, already went over those too in the hearing pathway, but make sure that you know the cochlea, because the cochlea is where transduction occurs. Sensation versus perception. Oh, I gotta sneeze. Hold on. Excuse me. Sensation is just the stimulation of your sensory receptors. So all the steps involved in the vision and hearing pathways, that's sensation. And then perception is how your brain makes sense of it all and organizes it. Types of deafness. Conduction is when there's damage to the eardrum or the bones and doesn't allow for the ear to pick up on the vibrations. Sensory neural involves damage to the cochlea and doesn't allow transduction to occur. And stimulation is involving damage to the hair cells. And sometimes a hearing aid will still help with that. Sensory adaptation says that we tend to only notice changes in our sensory experiences, that over time we adapt to a sensation. So for example, a strange smell, you may smell it even if it's a good smell or a bad smell, and after a while you don't smell it as much anymore. That's sensory adaptation. Also, like if you were to go into a dark room and at first you can't see well, but after a few minutes you can see better, that is sensory adaptation. You do need to make sure you recognize or know the taste sensations: sweet, sour, salty, bitter, and then umami was added as savory and oleogustus as the fat and oil one. The thalamus, remember that is the part of the brain that processes or actually relays sensory signals from the brain stem up into the different lobes. The only sensation that does not go through there is olfaction or smell. Transduction locations, remember for vision specifically, or generally it's on the retina, specifically it's in the ganglion and bipolar cells, and for hearing, generally it is in the cochlea, but specifically it's the basilar membrane and the organ of Corti. And then the vestibular sense and the semicircular canals. Remember that the vestibular sense is based on sensations in your semicircular canals, which are in your ears, and there are receptors there. So feeling dizzy would be based off of the fluid that's moving in your semicircular canals. All right, that's it.